All right, picture this. You're standing on a ledge 1,000 feet up. Below you, cold, hard concrete, but you're not scared. You're holding a weird-looking white device that hums with mysterious power. You grin, aim at the wall way over there, and pull the trigger. A swirling blue oval appears. Next, you aim at the floor right below you. An orange oval shimmers into existence. You take a deep breath, give a little salute to the imaginary crowd, and just step off the ledge. You fall for maybe 5 feet right into that orange glow. And then, for a split second, the world disappears. Suddenly, you're not falling anymore. You're flying. You burst out of that blue portal on the far wall, rocketing sideways at the exact speed you had built up during your short fall. You're a human cannonball, a majestic eagle made of pure momentum, soaring across the chasm with a triumphant yell. It feels incredible, like the universe just handed you a cheat code for gravity. This is the magic of the portal gun, an idea that has captured the minds of gamers and nerds like me for years. It's a device that lets you bend space to your will, turning a deadly drop into a high-speed launch. But here's the million-dollar question. If we ever built one of these things for real, what would actually happen to you? Is it all smooth sailing and physics-defying fun? Or would reality come crashing in with a whole bunch of inconvenient and frankly painful consequences? As a former NASA engineer who loves building crazy contraptions, I can't help but wonder. We're going to break down the science behind this awesome piece of fictional tech, from the fundamental laws of motion to what your squishy human body can actually handle. So grab your lab coat and a helmet. Things are about to get weird. Because behind every awesome video game mechanic is a mountain of fascinating and sometimes terrifying real-world physics. We'll explore why you fly out of the portal in the first place, what happens if you just keep falling through them forever, and the messy biological truth of what happens when flesh and bone meet extreme acceleration. The first rule of Portal Club is, you don't talk about Portal Club. Just kidding. The first rule is actually much cooler. Speedy thing goes in, speedy thing comes out. In the game, this is called conservation of momentum. It means that whatever speed and direction you have when you enter one portal, you have that exact same speed and direction when you exit the other one, just relative to the exit portal's orientation. So if you fall straight down into a portal on the floor and the exit portal is on a wall, you'll shoot out sideways. Your downward momentum has been instantly converted into sideways momentum. This might sound like space magic, but it's actually rooted in one of the most fundamental laws of our universe. Newton's first law of motion. You probably remember this one from school. An object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. When you go through a portal, the game pretends there are no extra forces. The portal simply changes your location and reorients your existing velocity vector. It's like picking up a spinning top and instantly placing it on another table without slowing it down. So, let's break it down even simpler. Imagine you're rolling a bowling ball at 10 miles per hour toward a portal. When it emerges from the exit portal, it's still going 10 miles per hour. The portal itself doesn't add or subtract energy. It's just a door. A very, very weird door that connects 2 different points in space. One of the most mind-bending things you can do with a portal gun is create an infinite loop. You shoot one portal on the ceiling and the other directly below it on the floor. Then, you just hop in. You fall through the floor portal only to emerge from the ceiling portal, and then you immediately start falling toward the floor portal again, and again, and again. In the game, you can just keep falling forever, accelerating faster and faster until you reach what's known as terminal velocity. At that point, your speed becomes constant, and you can fall endlessly, a prisoner of your own cleverness. But let's bring this into the real world. Would you really fall forever? The answer is a big, fat no. And the reason is something the game conveniently ignores: air resistance. Every time you fall through the air, you are colliding with trillions of tiny air molecules. This creates drag, a force that pushes against you and slows you down. In a portal loop, you'd still accelerate due to gravity, but you'd also be losing a tiny bit of energy as heat and sound every single time you pass through the air between the portals. It would be like a very, very inefficient engine. Eventually, you would reach a state of equilibrium, but not in a cool, infinite fall kind of way. The energy you gain from gravity during the short fall would eventually be perfectly matched by the energy you lose to air resistance. At that point, you wouldn't speed up anymore. Instead of an infinite acceleration loop, you'd just be stuck in a perpetual lukewarm tumble, like a sock in a low-power dryer. And that's not even getting into the other weird stuff. What happens to the air itself? As you fall, you push air into the bottom portal. Does that air come flying out of the top portal, creating a constant downward hurricane in your infinite loop chamber? So, we've established that you can use portals to launch yourself at incredible speeds. Let's say you engineer the perfect fall, a nice long drop into one portal to come screaming out of another one horizontally. You're flying. It's amazing. But then, you have to land. This is the part of the equation where your fragile, squishy human body has a serious disagreement with the laws of physics. The problem isn't the speed itself, it's the sudden change in speed, otherwise known as acceleration, or, in this case, deceleration. And our bodies do not like that one bit. Let's do some back-of-the-napkin math. If you fall for about 45 meters, that's around 150 feet or a 15-story building, you'll hit a speed of roughly 30 meters per second, which is almost 70 miles per hour. When you fly out of the exit portal and land, you have to go from 70 miles per hour to 0 in a very short amount of time. If you land on, say, a cushioned surface that lets you stop over the course of 1 second, you would experience about 3 Gs of force. That's what astronauts feel during a rocket launch. It's intense but survivable. But what if you don't have a nice, soft landing pad? What if you just hit a hard floor? Your stopping time would be much, much shorter, maybe around 0.1 seconds. In that scenario, the G-forces would be catastrophic. You'd experience over 30 Gs of force. To put that in perspective, fighter pilots are trained to handle up to 9 Gs for very brief periods, and even then, they risk blacking out. At 30 Gs, you're not just blacking out. Your internal organs would slam against the inside of your body, bones would snap, and blood vessels could rupture. It would be, to put it scientifically, a recipe for becoming a human pancake. So while the launch is exhilarating, the landing is the real killer. It's the classic physics problem. It's not the fall that gets you, it's the sudden stop at the end. Given everything we've talked about, if portal guns were real, they would be an absolute nightmare for any workplace safety organization. Imagine the Occupational Safety and Health Administration, or OSHA, trying to write a manual for this thing. The warning stickers alone would be a mile long and written in tiny, frantic text. It would be a hilarious clash between groundbreaking technology and painfully mundane bureaucracy. The first page of the Aperture Science Handheld Portal Device Manual would probably be a massive, all-caps legal disclaimer. Let's brainstorm some of the warning labels you'd definitely see plastered all over the device. Warning: sudden cessation of momentum may result in rapid, unscheduled disassembly of user. Or, how about caution? Do not operate within 500 feet of reflective surfaces, confused birds, or open containers of liquid. We don't know what will happen, but it won't be good. Another classic. Notice: maintain a safe distance from active portals. Spaghettification is a rare but non-zero risk if portal integrity is compromised during transit. They'd need a whole section on what not to put through the portals. The list would start with nuclear waste and end with your cousin Jerry, no matter how funny you think it would be. And the training course? It would be a week-long seminar in a stuffy conference room. Day 1 would be dedicated entirely to the don't look directly into the operational end of the device rule. Day 2 would cover the G-force calculations, complete with charts and graphs showing the precise fall height that transitions from fun to liquefied organs. You'd have to get certified to handle Class 4 spatio-temporal apertures, and your license would need to be renewed every 6 months, pending a psychological evaluation to ensure you haven't developed a God complex. The best part would be the official OSHA regulations for test chambers. All landing zones must be padded with a minimum of 10 feet of aerospace-grade foam. Emergency portal closure buttons must be present and comically large. A designated portal supervisor, wearing a bright orange vest, must be on duty at all times. So while we dream of the freedom and fun of a portal gun, the reality would be a world wrapped in red tape and common sense. And honestly, seeing an OSHA inspector scolding a rogue scientist for creating an unauthorized infinite loop might be just as entertaining as the game itself.